Hi everybody, today we're going to go over lesson 6.3, linear functions. Our essential question for today is how do you write a linear function given a table or graph? Go ahead and pause the video if you need to write this down. A linear function is a function whose graph is a non-vertical line. A linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. One important thing here that this definition mentions is the non-vertical line. So I would highlight or underline that part here. And we'll talk about that a little bit later. We've talked about y equals mx plus b, or m is a slope and b is a y-intercept in a previous lesson. So it's really important that you understand the different components of the slope-intercept form of an equation. Example 1, writing a linear function using a graph. It says use the graph to write a linear function that relates y to x. Now the easiest way to start off is by writing the slope-intercept form of an equation. We know that's going to be y equals mx plus b. Okay, and you can tell by looking at the dots here that they actually make a straight line. So if you wanted to connect them, you could with a straight line. Sometimes that helps you visualize things. So the first thing I can easily see is where my y-intercept is. So right here, I see that my line intercepts the y-axis at the ordered pair 0, -3. That means I can assume that my b is a -3, or simply -3. My slope, remember from reading a graph from left to right, is increasing. Are you walking up the hill or down the slide? We're walking up the hill, so that's a positive slope. To find your slope, you just simply find another dot that lies perfectly on an intersection. So we can count from one dot to the other. We know it's going to go up 3, 1, 2, 3, and over 2, 1, 2. So we're going up 3 to the right 2. That means our slope is 3/2. That's our m value. And then we just bring down the y and the x. So our function is y equals 3/2 x minus 3. Example 2, writing a linear function using a table. Use the table to write a linear function that relates to y. So in this case here, if you are comfortable with graphs, you can always go ahead and start by graphing the ordered pairs. So here you can see that by graphing the ordered pairs, you get something that looks like that. And of course, if you want to connect the dots with a line to help visualize your function, you can go ahead and do that. Now then you can go ahead and use the same process that we did in the last example. If you weren't so fond of graphs, you can still figure out what your equation would be using a different method. So we do start off with y equals mx plus b. And if you recall from a previous lesson, you know that your y-intercept is always going to be the value where x equals 0. So lucky for us, they gave us the y-intercept. And we know that 3 is a y-intercept because your x value equals 0. So remember, anytime you have an x value of 0, that is where you're going to have your y-intercept, okay? So our x value on the line here is 0 when y equals 3. So we're going to go ahead and put a plus 3 here for a y-intercept. You know you're going to bring down your y. You know you're going to bring down your x. And now we have to figure out what our m value is. Do you remember how you could do that without looking at the graph? If you remembered the slope formula, great. That's what you could do to find the slope. So remember that m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you can choose any two values from the table. So if I were to choose 0, 3 and negative 1, 5, I can make one of the pairs the 1 values and the others the 2 values. So I might want to make this x1, y1. This one could be x2, y2. And now I'm just going to plug my values in, right? So I'm going to have 5 minus 3 over negative 1 minus 0. That's going to give me 2 over negative 1. So that's a slope of negative 2. And I simply plug that in here. Now you can always check to see, did we do this correct? Well, let's look at the graph. Okay, we did have the y-intercept of 3, which we talked about earlier. And if we were to go down 2 and over 1, are we in line with the rest of the dots? Well, it sure looks like we are. Let's go ahead and connect. Yes, we still have a straight line. On your own, go ahead and pause the video and try these out. Use the graph or table to write a linear function that relates y to x. So here, again, you just have your dots and you can connect them with the line if that helps you out. So I can see right away that my y-intercept is at negative 1. So that's a minus 1. My slope is negative because I'm going down from left to right. So I know that I'm going to have a negative something for my slope. I'm going to choose these 2 dots here to count my slope. Remember, you can choose any 2 dots on the line. Choose 2 dots that are easy for you, 2 points that are easy for you. So here I'm going down 1 and over 2. That's going to be a negative 1 over 2. For the second one, they are so nice and they're giving us an ordered pair that tells us what our y-intercept is. So already I know my b value is going to be 2. So y equals mx plus 2. Now I have to figure out what my slope is. So if I wanted to use 0, 2 and 1, 2, I could do that. Some of you might notice something interesting here. All my y values are 2. How could that be, and what would that look like? Some of you already know what that means. If you don't, that's okay. Let's keep going with the process. So I'm going to make this one x1, y1, x2, y2. We're going to use a slope formula, which is m equals y2 minus y1 over x2 minus x1. Okay, that's going to be 2 minus 2 over 1 minus 0. So we get 0 over 1. 0 divided by anything is going to equal 0. So we have a slope of 0. Y equals 0x plus 2. Do we really need that there? No, so it's really y equals 2. So some of you said, I could already tell because every y value on this table is a 2. And we learned before that when all the y values are the same, you have a horizontal line. So this is my y-axis, and this is x. If this is 2, I have a line that goes straight through that 2, and that is my y equals 2 function. So good job if you remember that from before. Example 3, real life application. You are controlling an unmanned aerial vehicle for surveillance. The table shows the height y in thousands of feet of the UAV, X minutes after you start its descent from cruising altitude. Write a linear function that relates y to x. Interpret the slope and the y-intercept. Let's go ahead and use our y equals mx plus b function. And do we, first off, have something that tells us what our y-intercept is? Well, let's take a look at the chart. Remember that you know it's the y-intercept anytime your x value equals 0. So here they are being very helpful. We know that the starting point is 65 feet. Okay, now we have to figure out our slope. So of course that's our m value. You know you're going to have a y in your function. You know you're going to have an x. So we're going to find that missing value m. How would you do it? I would probably use the slope formula. So if I'm going to have 0, 65, and 10, 60, I'm going to label this as x1, y1. This will be my x2 and y2. Okay, and then I'm going to go ahead and use my formula. So m equals y2, that's 60, minus y1, 65, over 10, that's my x2, minus 0. Okay, so I have negative 5 over 10, which simplifies to negative 1/2. So here I have a negative 1/2. So my function is y equals negative 1/2 x plus 65. And some of you might have found the slope a different way. So some of you might have looked for patterns. So here you might have seen that this is decreasing by 5 each time, while this one here is increasing by 10. And since you know slope is rise over run, and that's your y value, change in y over change in x, that's going to be negative 5 over 10. You still get negative 1/2, right? So there's always more than one way to find something. Now what's important here is it says interpret the slope and the y-intercept. We've seen this before. They're asking for an explanation of what the slope means for this specific word problem. Can anybody out there tell me what you think the slope is? What's your interpretation? So good. It could be something like for every 10 minutes, the height of the vehicle decreases by 5,000 feet, right? When you translate that into the 1/2, you are decreasing 1,000 feet for every 2 minutes, right? And the y-intercept always is the starting point of when something's happening. So you could say that the y-intercept of 65 indicates that the aerial vehicle started at a height of 65,000 feet. Okay, now if you were to graph the linear function, the textbook has a graph for you, so it would look something like this. And then something that you might be asked to find is find the height of the vehicle when you stop the descent after 1 hour. So of course, this is in minutes, that's 60 minutes. So taking a look up to where it hits the graph, where does it hit? Okay, it is at about 35,000 feet. Okay, so don't forget your units. Stay tuned for part 2 of the lesson.